Math 2, Unit 6.6. Today our notes are on dilations. Okay, so when you are dilating something, you're either like expanding it and making it bigger, or you are shrinking it and making it smaller. But whenever you're using dilations, they are proportional. Okay, you with me? Yes?
Yeah.
Okay, so to dilate a segment by a scale factor n, with the center of the dilation at the origin. What is the origin? 0, 0. Most of the dilations that we're going to do are going to be dilating from the point 0, 0. Okay? You measured the distance from the origin to each point of the segment. Okay. So we are going to graph the dilation of the endpoints AB, which actually is already here, by a scale factor of 2. Okay? And center the dilation at the origin. And then you'll label our new points at A prime, B prime. Okay, when you have a scale factor, this means of 2, we're going to multiply the point by 2. Okay, so your scale factor is what you're going to be multiplying by. Okay, so to start with, what are the coordinates of A right now? Good. Negative 1, 2 is correct. And what is my ordered pair for B? Good. Negative 1, negative 2 is correct. Currently, right now, what is the length of AB in units?
4 units.
Very good. And so we're just going to write that as 4. But when I mean units, I'm talking about like it's going from here to here is 1 and it's 4. Okay. Now, the coordinates of AB, all we're going to do is take each of these points, and all you do is multiply them by 2. And so for A prime, what is negative 1 times 2? Good. And what is 2 times 2? Good. And then we're going to do B prime, and so we go negative 1 times 2, which is negative 2. And negative 2 times 2 is? Very good. And now we're going to plot those points on our graph and draw our line. So we go negative 2 up 1, 2, 3, 4. And that is A prime. And then negative 2 down 4. And that is B prime. And you can use your ID card, or if you want to get a ruler, you can. Or if you just want to draw your line, that's fine. I find that I draw straight lines when I use a ruler. Kind of weird, but that's a suggestion. Okay, so that is my new line. If you add that up, what is that length? 8. And so that means that also for the lengths, what do we do in order, if we're multiplied by 2 in order to get the 8? Okay? When you are finding your the center, if you were to take each of your values, your prime value and your original value, and draw a line through them, they end up hitting the center. So see right here how these end up going to the point 0, 0. And if I go both of my A's and I draw a line through, they also go through 0, 0. So when you draw a line, it ends up taking you to the center of your dilation. Okay? But like I said, almost everything that we're going to do is end up going through 0, 0, but there are a couple questions where they don't go through 0, 0. But you can find them by drawing lines through the original mark and your prime mark. Okay. And so here, how do the lengths of AB, line AB, and our prime line compare? 2 times as long, right? Okay. Yeah, and however you write that, you don't have to say it the same way as I do. As long as you're talking about that one is 2 times as long as the other, that is correct. Okay, so key concepts here is that dilations use scale factors to make a larger or smaller copy of a figure that is similar to the original figure. And similar, we know, means what? Similar means proportional, right? So remember how we had all of our similar figures and our similar triangles and they all had the same ratio? Okay, same thing with dilations. You're using something and it's going to have the same ratio, the same proportion. Okay, since dilations produce similar figures, we know that the dilation preserves what? Angle measure. That is correct. Good job. So that means that with all of our figures, they have congruent angles and proportional lengths, right? Okay, so the scale factor n of a dilation is the ratio of the length of the original image, so I'm just going to put image, to the corresponding lengths in the pre-image, with the image length always in the numerator. This does not make sense. So we're just going to talk about it in other words. So what do I mean? What they're saying is that your scale factor is you take your new image divided by the original image. Okay, or I could put this as the dilation over the, I'm going to put original. Okay, and so what do I mean by that? Well, the dilation length on our first example, how long was my dilation image? 8, right? My dilation image was 8, and then the original image had a length of 4, and 8 divided by 4 gives you the scale factor of 2, which we knew that it was. But let's say that they give you the images and they want to know the scale factor. That's what you would do. You would take your dilation and divide it by your original image. Okay. If the scale factor is greater than 1, and this is something I might highlight or circle. So if the scale factor is greater than 1, the dilation will enlarge the figure. If the scale factor is in between 0 and 1, and what numbers are in between 0 and 1? Fractions, right? Like 1/2, yeah, 1/3. The dilation will shrink, is exactly correct. The figure. All right, so we're going to do a dilation of 2, and we're going to do a dilation of 1/2. So this one is going to enlarge, and this one is going to shrink. Okay, do we see the difference in the numbers? Okay, so in order to enlarge and shrink, it's easiest to always start with your ordered pairs. Okay, so P, we have P, C, R, and N. Okay, what is the ordered pair for P? Good. -1, 2 is correct. For C, good. -2, 0. R is 0, -2. And N is 2, -2. Okay, I always like doing my primes right next to them because it's easy to kind of multiply through and see them. So we have P prime, C prime, R prime, N prime. So we're in a dilation of 2. What am I going to do? Multiply by 2. So -1 times 2 is -2, and 2 times 2 is 4. Am I going too fast? Okay, C. -2 times 2 is? Good. And then 0 times 2 is? 0. Good. For R, we have 0 times 2, which is 0. And then -2 times 2 is -4. And then N, we have 2 times 2, which is 4. And -2 times 2, which is good. And so now we're going to go and plot each of those points. So we go left 2, up 1, 2, 3, 4. And make sure you label each of your points. So that's P prime, -4, 0 is our C prime. R is at 0, -4. So we have r prime there, and then n prime is negative 4, negative 4. And again, I would suggest using a ruler. So we draw our lines, connecting our dots. Did I do something wrong? Thank you. Okay, we're going to turn those air conditionings off. Thank you. So hopefully you can count better than I can in order to get your points in the correct locations, but that is what it is supposed to look like. Let go. Too long. So you like count to 5. 1, 2, 3, 4, 5, and then let go. There you go. Thank you. Okay. So any questions there on dilation of 2? Okay. Dilation of a half. So this is going to make it shrink. So again, we need to first write our original ordered pairs. So I have M, Z, and Y. The ordered pair for M is what? 2, 1. Z is? Good. And then Y is? 5, negative 2? Oh, thank you. And then Y is?
5, negative 2.
Good. Okay, and I don't have enough room to write them right next to each other. So I'm just going to go down here. So M prime. When I multiply 2 times a half, what happens? It becomes 1. If you need to write it out, 2 times 1/2, do you see how the 2's end up canceling and we just get 1? Okay, 1 times a half is 0.5. And we can write that as 0.5 or a half. I'm going to do 0.5 because sometimes when you're graphing, it's easier to understand 0.5. It's totally up to you, though. Either is good. Z prime. 0 times a half is 0. Now, when I go negative 3 times 1/2, I get negative 3 over 2, which is what? Negative 1.5. Are we okay with that? Okay, and then Y. Okay, good. 2.5 and negative 1. All right, any questions there? So when we're plotting our points, over 1 up 0.5 is right here. That's our M prime. So for 0.5, we're just going in between the two numbers, correct? Okay, for Z prime, we have 0 and then negative 1.5. So there is our Z prime. And then Y prime is 2.5, negative 1. And then go ahead and draw your lines. Here, come. What do you notice about these lines? If we're looking at these figures, MY, the prime versus the original, those lines are what? What do you see, Stephen? I think you're not understanding my question, so I'm going to kind of show you. So this line and this line, what do we notice about those two lines? The prime line from my original line. They're parallel, okay? So all of these lines end up being parallel to each other, okay? And again, they're shrinking or enlarging, and right now we're going across the 0. So when they shrink and enlarge it, it's going with the 0. When they're like pulling it out or shrinking it down, that's kind of like your starting point for moving it. Okay? All right, let's go ahead and move on to the next page. Sometimes you will see it, this D, guess what D stands for? Dilation. Okay, so D stands for dilation. This N in the front stands for your scale factor. And then this is your origin, or where you would originally end up starting for starting your dilation. But if you have a 0 there, it means that it's at your origin, which is 0, 0. Okay, so you have triangle CEP, and then you have your figure or your triangle C prime, E prime, P prime. And they first want to know, is it an enlargement or a reduction? So starting at your original, can you guys tell which ones are primes? So the primes, if you can't see, these ones have the little markings. And so this is the prime. So it starts at the original figure and then it goes to the prime. So what happened? Did it enlarge or shrink? Enlarge. Good. So just looking at it, we can tell that it enlarged. So I'm going to put enlargement. And then they want to know the scale factor. They want to know what happened. Now we could add the lengths, right? And then see what happened by doing your length. Remember? Your original divided by, your new one divided by your original. But sometimes if we just look at the points, it would be easier. Okay? And so let's go ahead and write down the points. So the point for C is what? 0, 1. That's your original right here. So my point for C is at 0, 1. And then I have E and P, sorry. And my point for E is at -1, -1, right? And then for P, it's at, good. Okay, and then let's go ahead and write down each of these primes points and see if we can tell what they multiplied by or divided by in order to get the new figure. So the new figure, where's my C value? So automatically right there, what do you think they multiplied by?
2.
Okay, I think so too, but let's just double check with everything else. So on E, it went where? -2, -2. And then P is 2, 0. So enlargement, and it has a scale factor of 2. Okay, questions? Okay, so this next one, we have a dilation of what? 1/2. Okay, so let's go ahead and write down our original Z. I think these letters over here are wrong. So this should be Q, S, and Z, not V. Okay, so let's write those down. So Q, S, and Z. Can you guys write down each of those ordered pairs to start with? Okay, so what's Q?
14.
Good. S and Z.
4.
Good. Okay, and if we're doing a scale factor of 1/2, let's go ahead and write down what our primes should be. Okay, so 4 times 1/2 ends up making 2, and 2 times 1/2 makes 1. Okay, when I go -1 times 1/2, you get what? -0.5. And then 3 times 1/2 will make what? 1.5. And then my z prime, when I multiply each of those by 1/2, it'll be 2, 2. So let's go ahead and plot those points. So q prime, I'm going 2 up 1. And we have q prime. And then we have negative 0.5 and 1.5. So that should be my s prime. And then z prime is 2 up 2. And we can draw our lines. And you can tell that it has been shrunk, right? Okay, so how are ZQ and the prime figure ZQ related? So what are things that we know about them? Very good. So let's go ahead and write that line ZQ and our Z prime Q prime. Those lines are parallel. If I can spell it. Okay. What else do we know about them? They are proportional. Okay. Specifically how? ZQ is bigger or smaller? So it's how much bigger? Or 2 times. So ZQ is 2 times bigger than Z prime Q prime. And then specifically it says, what effects do dilations have on lines? So each of these lines, what kind of effects do they have on the lines? They either shrink or enlarge. Good. So their lengths work. I'm going to put shrink or enlarge. So whenever you use a dilation, you are going to either shrink or enlarge. Okay, so this next one just asks for you to find the coordinates of the image for a dilation at 0, 0 with the center of 0, 0 given the specific scale factors. So this first one together, what would be my A prime? -2, -4, because all I'm doing is what to each of the points? Multiplying by 2, very good. So G prime, I'll end up getting 4, 4, very good. And then X prime will be
2, -4.
Very good, 2, -4. Okay? For B, we are now multiplying by 1, 4. Okay? If you wanted to, you could plug some of these into your calculator in order to get the decimals if you want to. But when you multiply 2 times 1/4, what do you end up getting? See here how like the 2's and the 4's, you would get 2 over 4, and that does reduce to 1/2 or 0.5. When you multiply 1 times 1/4, what do you get? 0.25. Is anybody confused by that? And you guys know how, like, for 1/4 in the calculator, you just type 1 divided by 4 to get 0.25 if you didn't know. Okay, X prime, what is that ordered pair going to be when you... Oh, I skipped F. Here we go. F prime, what's that going to be? Good, 0.75. And what? 1. Good. And then X prime is? Should be 1.25, right? Because you'd have 5 times 1/4, and that's 5 over 4, and if you plug that in, that's 1.25. And then what's the other value, the Y value? For 0.75 for the Y on the X prime, right? Okay, and then W prime, 2 times 1/4, we've already done that. What does that end up making? 0.5, and then -1 times 1/4 would be -0.25, right? Okay, if you dilate ABC with a scale factor of 3, center at the origin, what can you say about the length of the prime figure compared to the length of the original figure? What do you think? Go ahead, Spencer.
The prime one would be 3 times as large.
Very good. That's perfect. So I'm going to write that as A prime, B prime, that segment, will be 3 times as large as line AB. And you want to pay attention to what they're asking you because it could be 1/3 of the size as well if you're going the opposite direction, right? Okay. And then it says, what can you say about the angles in our prime figure? Very good. And specifically, we would say the angles will be congruent. Doesn't congruent mean the same or equal? Yeah? And so, or you could have abbreviated angles are congruent. All right, questions? No?